Show for all real numbers a, b greater than 0 that a plus b is greater or equal to 2 root ab. Okay, so the first thing we're going to do is get everything over to one side. So the 2 root ab comes over the inequality sign, becomes minus 2 root ab. So we have a plus b minus 2 root ab greater or equal to 0. Then we're going to factorize root ab so that we have root a multiplied by root b. So we have a plus b minus 2 times root a times root b greater or equal to 0. Then we're going to rearrange our equation so that the minus 2 root a root b is in the center. So we have a minus 2 root a root b plus b is greater or equal to 0. Then we're going to factorize a minus 2 root a root b plus b, and we're going to get root a minus root b multiplied by root a minus root b. And this is greater or equal to 0. And since what we've got inside both sets of brackets is exactly the same, we can simplify to say root a minus root b squared is greater or equal to 0. And this is true. Because remember, any number squared will be positive, which is going to be greater or equal to 0. Because any number, whether it's negative or positive, when it's multiplied by itself will be a positive, because a plus by a plus gives a plus, and a minus by minus gives a plus. So any number squared will be positive, and another way of saying positive is greater or equal to 0. So any number squared will be greater or equal to 0, so this is true. So how did we factorize a minus 2 root a root b plus b? Well, we can break down the minus 2 root a root b to be minus root a root b minus root a root b. This is technically minus 1 root a root b and minus 1 root a root b, which would actually give us minus 2 root a root b. So we can break it down into 4 terms, and then what I'm going to do is factorize the first 2 and then factorize the second 2. So factorizing a minus root a root b, well, the highest common factor is going to be root a, because remember the factors of a are root a times root a. So root a into a leaves us with root a, because root a multiplied by root a is a. And root a into minus root a root b will leave us with minus root b. So now I'm going to factorize the second 2 terms. So minus root b will divide into minus root a root b and leave us with root a. And minus root b will divide into b and leave us with minus root b, because minus root b multiplied by minus root b gives us b, because the factors of b are root b times root b, or, in this case, minus root b times minus root b. Now we have the same thing inside both sets of brackets, so we've got root a minus root b and root a minus root b, so that's going to be one factor. And then what's outside the brackets is root a minus root b, which is going to be in our other set of brackets. So we have root a minus root b multiplied by root a minus root b, which is what we had down here. And again, we end up having root a minus root b squared. Part 2. Show that a plus b multiplied by 1 over a plus 1 over b is equal to a plus b squared all over ab. So we have 2 sets of brackets, so we're going to have to expand them. So we're going to crack open the first set of brackets, or crack open the first egg, and we're going to bring down the first term, which is an a, but I'm going to change it to a over 1. And we're going to stick on the second set of brackets, which is 1 over a plus 1 over b, and bring down our plus. And then we're going to bring down the b, but again I'm going to change it to b over 1, so that it's a fraction, and again stick on the second egg, stick on the second set of brackets. So now I have all fractions, and I'm going to multiply my fractions, and remember, when we're multiplying fractions, top by top, bottom by bottom. So a over 1 times 1 over a, top by top, bottom by bottom, we'd end up getting a over a, and anything divided by itself gives us 1, so we end up getting 1. So remember, when you multiply a fraction by its reciprocal, you get 1. And then a over 1 times 1 over b, top by top, bottom by bottom. A times 1 is a, and 1 times b is b, so you get a over b. Then b over 1 times 1 over a, b over by 1 you get b, 1 by a you get a. And then b over 1 multiplied by 1 over b, again multiplying a fraction by its reciprocal, you get 1. So 1 we can rewrite as 1 over 1. AB stays as it is, BA stays as it is, and 1 we can write as 1 over 1 again. So we have 4 fractions and we want to add them together, so we need to get a common denominator. So our common denominator is going to be AB. So 1 into AB will give us AB, and AB times 1 is AB. B into AB, the b's will cancel, leaving us with A, and A times A is A squared. A into AB, the a's will cancel, leaving us with B, and B times B is B squared. And 1 into AB will leave us with AB, and AB times 1 is AB. So we have AB plus A squared plus B squared plus AB all over AB. So we can put the AB's together to give us 2AB. So we have A squared plus 2AB plus B squared is all over AB. So next what we want to do is factorize our numerator. So A squared plus 2AB plus B squared, we're going to break it down to be A squared plus AB plus B squared. So technically this is plus 1AB and plus 1AB. We're going to start by factorizing the first two terms. So A is our highest common factor. A into A squared leaves us with A into AB leaves us with B. Then we're going to factorize the second two terms. And B is our highest common factor. B into AB leaves us with A, B into B squared leaves us with B. We notice we have A plus B inside both brackets, so A plus B is our first factor. And then we bring down the A and the plus B, so A plus B is also our second factor. So we end up getting A plus B times A plus B all over AB, which gives us A plus B squared all over AB, which is what we wanted. Deduce that A plus B times 1 over A plus 1 over B is greater or equal to 4. So we can rewrite A plus B times 1 over A plus 1 over B as A plus B squared all over AB. So we got this from part 2. And we can let this be greater or equal to 4. So we can multiply out these brackets. So A plus B squared gives us A plus B times A plus B. And A plus B times A plus B is A squared plus 2AB plus B squared. That's still all over AB. And that's still greater or equal to 4. We're going to get rid of the fraction part, so we're going to multiply both sides by the denominator. So multiplying both sides by AB will cancel out the AB in our denominator. So on the right hand side we'll have 4 times AB, which is 4AB. We're going to bring the 4AB over the equal sign, it becomes minus 4AB, and let that be greater or equal to 0. So 2AB minus 4AB is minus 2AB. So we're going to factorize A squared minus 2AB plus B squared. So we have A squared minus 2AB plus B squared. We're going to break down the minus 2AB to be minus AB minus AB. Then we're going to factorize the first two terms. So A into A squared leaves us with A into minus AB leaves us with minus B. Then we're going to factorize the second two terms. B into minus AB leaves us with minus A, B into B squared leaves us with B. So we want to change the signs of the plus B, the minus A and the plus B so that we've got the same thing in each set of brackets. So we get minus B times A minus B. Now we've got the same thing in both sets of brackets, A minus B, so that's one of our factors. Then bring down the A and the minus B, so that's our second factor. So A squared minus 2AB plus B squared factorizes to A minus B times A minus B, and this is greater or equal to 0, which will simplify to A minus B squared, which is greater or equal to 0, which is true, because any number squared will be positive, which is greater or equal to 0. So this statement here is true. So therefore, this is true.